So hi everyone. So yeah, first and foremost, I want to start off with a motivating example, because for the most part, pretty much everyone on this session right now, for the most part, you're either you're in grad school, or more likely you're either a coder or you're in some kind of job which requires you to do a series of tasks every day. And you're all thinking the same thing, exactly what I'm thinking. Like, wouldn't it be great if I could use AI, and more specifically agents, to perform some of those tasks, especially those tasks we call toil tasks that are repetitive, that I need to do to get my job done, but at the end of the day, it doesn't really help my job. If I have to watch, if my inbox gets 80 emails every day, I'd rather be responding to the 7 or 8 emails that I should be responding to, and not having to screen out the other 80 or filter out the other 80. So things like that. So we all have workflows. So I'm going to tell you one of the workflows that we've been working towards, because the first question is, why MCP? Why am I talking about it? And here's a motivating example. And again, I'm going to describe a workflow. It's very particular to the venture capital finance industry. But I think if you think about this workflow yourselves, you will see you have many workflows like this. It doesn't matter if you're an engineer, in sales or marketing, something like that. And it goes something like that. So in the VC industry, as Anastasia mentions, I'm a venture partner at an AI-first venture firm called Coracle Ventures. And by the way, if there's any startups on this call, you're looking for funding, especially in the seed round, pre-seed and seed, let me know. I'll share my LinkedIn at the end of this. But in the VC business, we spend a lot of our time sourcing. Where are the founders? Where are the startups? How do we get our holes in that? Deal sourcing. Then once we do find a deal, we have to screen them. Someone may come to us and say, hey, I got a great deal for you. We want to transform how images are used by doctors in the radiology department. We have a great idea. Here's the size of the market. We have to do a lot of work there, because what we don't want to be is subjective. We have to look at a lot of deals, and as people, we have limited time, limited focus. So screening is a big part of that. And then most venture capital firms have what they call a investment committee. So if you're a venture partner like me, you have to bring your deal in front of the investment committee, and the investment committee will vote. Usually everyone gets a vote, and they'll vote whether to continue that deal or to invest or not invest, right? And that's a pretty tough job, because let's say someone comes to me and they pitch, hey, we want to do robotics for fruit picking in agriculture. Well, I might know a little bit about robotics, and I might know a little bit about agriculture, having grown up in a farm myself. But am I an expert in robotics for fruit picking? No. So I have to become an expert for robotics and fruit picking. And I need to read all this kind of research, talk to people who are experts in the field. Where do I find them? And then when I get in front of the investment committee, they're going to ask me all these kind of questions around this. So like the startup, I have to become an expert in that topic for that given meeting. And that's kind of a hard part of this VC journey. And then the next part is once, let's say, we invest in that robotics fruit picking company, we have to support that startup. Trust me, let's say you raise 5 million in a startup. You think you've made it? No, like the hard work begins. Try to hire smart people in this AI environment. Very hard. Your go-to-market strategy, your sales strategy, all these things you probably never thought of as an individual contributor. You have to start working those. And what we want to do is support our startups with things like a go-to-market strategy. What tools can they use for sales, marketing? What tools can they do for lead gen? How do they build a good deck for their first customers? How do they find out where their customers are? Things like that. Like, yeah, a lot of times the startups have the examples, but a good venture firm will support that. And again, that's a lot of emails, reading a lot of reports, doing a lot of research. So I think you kind of see where this is going. And then we want to maybe, or most probably, when you invest in a firm, a startup, you want to do follow-on investing, because eventually they have to be acquired or do an IPO. And as a venture firm, you have to do what we call follow-on investing. So How is this company being viewed that you funded in the market? Like, what are people saying about it on Product Hunt? What are they saying about it in Hacker News or Reddit? If it's that kind of company, you know, like, so this is a lot of work. It's a lot of grunt work that goes into this. So when we started Cortical in 2021, at the very time we said we want to invest in AI, but we want to use AI to find the next generation of AI companies. And to live up to that, we started building out these platforms. So this is back in 2021. So we started a people database because, you know, startups are based on people. We started a research database, a companies database. Then we did things like entity resolution, so we can understand what the companies were. They had funding, not funding. Did a bunch of data cleaning, integration. The next thing we did was we did what a lot of people were doing at the time with ChatGPT 3 and 3.5. We built out our vector embedding database with one of the companies we invested in, Weaviate, if you know Weaviate by any chance. We built out our models. We did our model training. So we're using XGBoost, linear regression, different kinds of models to do different kinds of things. Could be topic modeling. And then we fed all these signals into a relational database. And we built all these signals. Like, we'd be able to signal, well, based on what this person did on LinkedIn, they might be moving their jobs. They might be resigning from OpenAI or Microsoft or one of the big AI companies, and maybe they're going to start an AI startup, or they just registered this company, or they launched a new website, or they just launched a product on GitHub and it's got 5,000 stars. Maybe we should talk to that person, right? So my background is a bit in financial engineering, quant finance, and in that background, you build, you know, did you ever hear the book Signal from the Noise? So we build up a bunch of signals, and we put all these signals on a dashboard for our venture partners and our limited partners to view. So we thought this was great. But, you know, like all dashboards, sometimes they pay attention to it and sometimes not. And a lot of times there were missing opportunities. So we said, we'll do one better. We'll try and put some large language models in there. So we're doing a lot of data collection analysis. And it would take, even with these signals, like, what does this signal mean? So, okay, someone just left their job. Are they taking a sabbatical? Are they actually starting a new company? Can you connect the dots for me? No, couldn't really connect the dots. So with agentic AI, what we did was we started building a bunch of agents. So in 2022 and 2023, we had a people agent, we had an open source agent, we had a research agent, activity agent, a venture agent. And all these were great. We could go to our agent, just like you go to ChatGPT, tell me who's the world leading expert in robotics fruit pickers, because I want to talk to that person about the startup, or the startup might want to hire that person. Tell me the latest research on dexterity for robot hands or something like that, right? So these agents were great. But the problem with all these agents was the same problem you have. We were busy people. So we noticed that our LPs and our venture partners weren't using this a whole lot, because an agent requires you to go in there, have a conversation, get some information out of that, and then go do something with that. Do something with that data, and that wasn't working very well as well. So, of course, when agentic AI came out, and when I say when agentic AI came out, it's only really been around in my mind 12 to 16 months at best, because it took a while for, you know, even though Crew AI and LangChain, a lot of these frameworks have been around a while, like really, I don't think that agentic AI really came into its own until 2024. So we built all these agents, and then all of a sudden we're connected to LinkedIn, PitchBook, Notion, are two platforms you use a lot in VC. Crunchbase is another one. Apollo AI, if you do sales, you know that. Archive for research, Gmail for communication, Google Docs for reports, presentations, Hacker News, Reddit for understanding what's going on in the market, RSS for news data feeds, and GitHub for understanding what's going on in open source, right? So we had all these data sources within our agents, but we weren't able to connect them. So that was a big problem. So, of course, we decided that, first of all, we need to agentify this stuff. We need to automate this process. So instead of doing that, pulling information from our system, we were going to be able to push it. We were able to build newsletters and emails, voice memos, whatever you can think of, automate that workflow, that difficult workflow we have that requires a lot of specialists. How can we agentify that, right? And sorry, I'll just check here for questions, see if this is resonating at all. Yeah, so great. So when we built out all these platforms here, the problem is, if you ever tried to do this, let's say when we built the people agent, we had to have, there is no API to LinkedIn, so I can't really divulge how we got that data, but a few of those sources, like, what was the one that was just shut down? Was it Proxy Curl? Yeah. LinkedIn sued Proxy Curl, so shut that down. So you got to be very careful where you get data from your data sources. But PitchBook has an API, Notion is an API, GitHub is a fantastic API. All of these have fantastic APIs, right? More or less. But the issue was with our agents, we had to connect to every one of those APIs and more. This is not the full list here. I had to hold some back. But these are all one-to-one connections of all. And second of all, we had to rebuild those connections with some abstraction every time we wanted to build a new agent. Because unlike Sam Altman and OpenAI, we don't believe there's one agent to rule them all. We wanted small language models and specialized agents, right? So in November of 24, 25th of November, so you could almost say December, that's around Thanksgiving, Anthropic launched what they called MCP. I read this memo and then ignored it for 3 months. Like most people in the industry, I was like, okay, this sounds cool, but literally who cares? Because like everyone else in the industry, for the most part, the 99.9%, I wait for other people to do something that's meaningful before I jump on the wagon. So anyway, they released this announcement about model context protocol. And in addition to that, this is when I started paying more attention. They launched this web page here as well. And don't worry, these links are in the resources. But if you want to check it out, you can check it out here. And these links will be in the resources. So they also provided a page here where it introduces this. And by the way, if you're using ChatGPT and Anthropic or anything else to like tell me about MCP, it'll do a great job. But nothing beats just going and reading about how this works. Like even if you're non-technical, like this is a 30-minute read at maximum if you went through the whole thing. Like it's just a 30-minute read. And most of the blogs and a lot of presentations like the one I'm giving you is based on information in here anyway. So why not go to the source? And it has a community in here as well. So those are a few good resources for you. Now, the reason why we were so excited about MCP, once we kind of clued in, because again, it took us 4 or 5 months to realize the potential here, was what it could do in terms of building multi-agents, right? And there's a lot been said about MCP over the last 5 or 6 months. I haven't used MCP now and trying to introduce it to our workflow. I can say, like most things, it's useful, it's helpful, but it's nowhere near the panacea, the silver bullets that a lot of people proclaim it to be. Like, it doesn't change everything. In fact, it's just another layer of complexity. It lessens complexity in one area and increases complexity in another. But at the same time, it's a very useful thing to have, because I think it's step one in building protocols for multi-agent systems. So we'll have either an improved MCP or better versions of this come in the future. So it's good that you're here today. It's good you're paying attention, because I want to walk through the good, the bad, the ugly of MCP. So first, I want to introduce you to MCP. I assume if you're doing this, you haven't really played around much with it or done much with it. Understand the system protocols, core concepts of, and then I want to talk about multi-agent systems, and then look at some applications, explain the notebooks, because again, we only have an hour total for this session, and we're already 20 minutes in. So to understand MCP, you really need to understand the agents. And there's a lot of hype around agents, but and everyone's got their definition, but mine one is pretty simple. It's a suite of tools, and the tools can be the ones I just showed you. It can be access to an API like LinkedIn, Apollo. So anything, any software that was built for marketing, sales, operations, healthcare, finance, federal government, they literally all have APIs these days. And those APIs can be turned into tools, right? Or you can do generative tools, create images, video, text, so you name it, generate an email. These are what we all call collectively as tools. It has tools, has a brain, which is a large language model, ChatGPT 4, 5, Anthropic, Claude, open source models, DeepSeek, whatever you want. And it has memory. And the memory is very, very important because there's a lot that relies on memory. And this is kind of like the part that people ignore. And it's kind of easy to ignore because when you start building agents, there's only 1 or 2 lines for memory, but this is where the context is. This is where the agent should know what its job is. It should know what it's supposed to do. It should remember the last task it did, but memory is very important. So when you have a single agent, you can do things like you can plan, you can be goal orientated, like book a restaurant is the one that people always use. You know, the one we're trying to build this for is, can I take, someone submits a presentation to us, a pitch to us. Basically, I want to ask the agent, is this worth our time? Should we follow up with this person or not? So we wanted to do autonomous decision-making, and that's the key thing here, autonomous decision-making. Because remember, when you interface with a chatbot like ChatGPT 5, there's nothing autonomous about it. And yeah, it'll help you make a decision, but you're making a decision. It's suggesting a decision, but it's not making one. And it can use multiple tools and systems. And a key one here, it's self-monitoring and adjustment. We just had a call with Matt Brenz, who I forget, sorry. It's a cortical startup. He did a session on vibe coding, and he was showing how agents can be self-healing. And how are they self-healing? Because if you ever use Google Colabs and your code breaks, you can ask Gemini to look at my code and fix my code. But that's you interviewing with it. But imagine an agent just goes a step further, just looks at the logs of your code as it's compiling. And as it looks at the logs, it sees the errors in the logs or sees the issues, and then goes ahead and autonomously monitors those logs and fix the errors as it sees the errors in the logs. So a very simple example of looking at logs to fix a code system. And the same can be said for data. Imagine you're an analyst and your system logs are showing up, this data is not formatted correctly. Well, maybe an agent can go and fix that, right? So people get very confused and they think self-monitoring and self-healing agents are kind of nonsense, but no. There's simple examples out there that can do this. But the real fun begins when we think about multi-agent systems. OpenAI has really messed this slide up for me because I was always a fan of their reasoning models and then their worker models. So if you think of O3, O1 as a reasoning model, a planner model, they're very good at planning and reasoning and doing deep research. And then the worker agent could be 4.1 or 4.5. Or even something cheaper like Llama 3 as an open source model, or some of the Quen models. But anyway, they still have that in the OpenAI because I do believe having a fast model, a slow model, a planning model, but you have all these worker agents, and the worker agents themselves, and again, there's always debates around this, like one model can do everything, or one agent can do everything. Why do you want to have a schedule agent? Because if you work in finance like I did, or you work in healthcare, or you work in different industries, let's say you work in logistics, scheduling is everything. Scheduling can be the difference between making a profit and a loss. This is a very, very complicated thing. Like imagine I wanted a restaurant agent knows how to book restaurants. Would I trust ChatGPT in its current form, GPT-5, to book me a restaurant? Or if I was a restaurant, would I want GPT-5 making reservations for me? No. So I do believe in this kind of planning worker paradigm, which OpenAI came out with itself, and it kind of follows the client server paradigm to a certain degree, not the messaging protocol, but our kind of the database protocols we have. So and again, I haven't gotten to MCP yet because in order to understand MCP, this is important. So here's some more complicated breakdown of what an agent is, because agents are actually much more complicated than what I showed and how people kind of describe an agent with tools, memory, and an NLM brain. They're much more complicated than that when you start working with them. And by the way, this slide is from our Introduction to Agents Bootcamp. So that introduction to AI agents in our bootcamp, we'll go into this in much more detail. But excuse me, I'm going to go over this real quickly. But interface to an agent, you might be using an API, you might be using text and chat, it might be voice. Is one of my favorite ways to work with agents right now is voice. It might be multimodal. You might show them an image. It might be a signal, sensory. Like think of an autonomous car, autonomous fridge, autonomous machines, robots, sensory, other agents. And a lot what you see now with a lot of agents is another agent, right? I build an agent that's very good at something. And that might connect to another agent, right? So don't forget about other agents. But here's where it kind of gets interesting. So if you think about the knowledge and memory layer, I'm sure many of you know about short-term memory and system memory. System memory, you might be providing a system prompt to ChatGPT or Anthropic saying, hey, I'm a venture capitalist. Here's my investment thesis, or I'm a marketing for a healthcare firm. Here's what we're allowed to market, and here's what we're allowed to do, or I'm a lawyer. You know, you give it system memory. Like no matter what else you do, this is your system memory. This is your root memory. Episodic memory. This is something we use a lot in finance. Imagine anything with time series, past trading history, what you like to trade, what happened last week in the markets. Like when you think of time series episodes, I was talking to another startup a few weeks ago where they were doing monitoring electricity usage in a house. Episodic memory could be what happened during the last storm, what happens in January versus what happens in June. Procedural memory. An agent is very important. They follow a certain procedure and they do that in lockstep, because you may ask yourself, well, how am I going to trust these agentic workflows? And let's say it is a procedural workflow, right? You have to do step 1 through 10. Well, you want locked down, evaluated, verified procedural memory, right? You may say, well, why isn't procedural episodic memory in long-term memory? Well, maybe it should be. But generally, long-term memory may be pretty much everything that's been trained on, everything on the web. Short-term memory, what might be what I just talked to you about in this chat, and that's it. And then when we start the next chat, I don't care about short-term memory. I just care about long-term and system memory and episodic and whatever. But memory is very complicated. Sorry, I don't want to overcomplicate it, but memory is quite involved. And then you also have the reasoning and decision-making layer. Think that famous book, Thinking Fast and Slow, System 1 and System 2 memory. Anthropic last year was the first one to come out with that. What ChatGPT is trying to be right now, by going between fast memory and slow memory, they're thinking about System 1 and System 2. Remember, System 1 is what's 2 times 2? You don't have to think about it. It's 4. You learn it by rote. What's 7 times 73.5? Not going to try that. There you got to go through your mathematical system in your head. Automation layer, won't talk about that, but anyway. So the agents themselves, like a single agent, kind of have aspects of this, right? And certain frameworks have this, like LangChain, LambIndex, Crew AI, another one. Some do and some don't. And so anyway, but don't worry about this too much, because the thing I want to kind of focus on is kind of the MCP and the communication layer, because, and of course you have an orchestration layer as well. And again, even if you're non-technical, look at this slide and think about that, because maybe the agents people are building for you, they don't have good procedural memory, or maybe they should. They don't have good episodic memory. So don't think of memory as one thing. Memory can be whatever you think you need it to be. Again, we covered this in the September bootcamp. So the problem pre-MCP. So again, now I talked about memory so much. When I say they had no shared memory, all these different agents, and they'd know different types of shared memory. Because let's say I wanted episodic memory across 5 of my agents, and maybe the planner agent knew nothing about episodic memory, right? So this no shared memory, which almost translates into no context, was a huge issue, right? Because that led to a lack of context, and a lack of context, it makes everything very brittle and makes collaboration very hard. And the other issue too was there was dozens of frameworks have coming out. I'm sure you've seen many of them, but there was no shared protocol. So you had all these frameworks to build agents and multi-agent systems, but those frameworks and multi-agents didn't talk to each other, right? And a lot of those frameworks had used different languages. Languages being anything from a programming language to how they communicate each other using JSON or something else. And then it became necessary because multi-agent systems, which everyone started to get excited about, they need a shared memory, they need context, and they need structured roles, right? So if I want to research agents, then I need an agent. I need to build an agent that's good at research. If I want an agent that's very good at sending emails, making sure the emails don't go to the wrong people, that the email doesn't sound like it was written by a chatbot, that it looks at my do not email list and things like that, or knows not how to spam people, or if it has to send an email in a day, because we've seen this, You tell an agent, send 1,000 emails, it'll do it in 5 minutes. And then guess what? Your Gmail or whatever else you use is going to get shut down and you're out of business, right? So trust me, there's all these domain expertise that these agents need to learn. And fragmentation is an issue, and that's it. So why MCP? Because everyone wanted to speak to everyone else. And this is, I forget what I generate this image with. I think it was either DALL-E 3 or VO from VO3 from Google. One of the other. But the MCP solution introduces a shared context and message protocol. So again, OpenAI's got open message protocol, I think it's called. Lots of message protocols out there, but not one that everyone kind of use. And it wanted, because think about what an agent is. It has a role, it has a goal, it has memory, right? And that protocol had to align across roles, goals, and memory. At the end of the day, it acts like an API layer for the agent system. And you're kind of saying to yourself, well, we really need one more API. Yes, we do. And I'll show you why. And why it took off, I don't know why it took off. If you'd asked me in December of 2024, is this one going to rise above the other? I don't know. Well, for a few reasons. I think Anthropic is known for doing thoughtful, good stuff. They're seen as a honest broker in the AI market, like with their emphasis on openness, security, trustworthiness. So I think even though they're usually number 2 or 3 in the market, or number 1, depending who you talk to. But I think that was a large part of it. And also as well, at the same time, there was a lot of frameworks and people were really getting saying that these multi-agent system is mostly just hype and it's not working, because by March and April of that year, we were trying to do this as well. And to be honest, apart from a few sandbox toy examples, we couldn't get it to work either. Even though the frameworks we were using were great frameworks. And I mean, if we couldn't get it to work, we could get it to do like, tiny project input. I couldn't get it to be like a autonomous VC agent, for example. And this is what drove it was crazy as well. Because if you ever started working with agents, with all the different components, it's another layer of abstraction. So people still do complain about the black box nature of LLMs. And then you wrap an agent around that. And the evaluations got much harder. The validations got much harder. The debugging got much harder. So instead of agents making our lives easier, they ended up making our lives more complicated. I wouldn't say harder, but more complicated. But that's because it was early days, and it still is early days. But if you ever try to do this, like the debugging, the scaling, the interoperability was a major blocker for artists. And so everyone recognized by the time MCP came out, and a few people a lot smarter than me started using it and saying it goes some way to alleviating this to a certain degree. Because remember, the agents I was building, it had many-to-many connections. So every agent I built had many connections to many tools. And we were trying to put our memory into RAG and long-term memory and systems like that. And that's another point about human loop here. So before MCP, this is pretty much, we would connect to GitHub, to Gmail, to Notion. Every agent we built, not just the people agent people who interact with, we could have all these different agents. They all had to have their unique API, not just like GitHub would go to every single LLM or agent we're using. So imagine 3 of this multiplied by 30 is 90, but we actually didn't have 3 of these. We had something like 20 to 30 services we use across dozens and dozens of agents. And all of a sudden you had hundreds of connections to maintain that were brittle, that were going down. And do you know any coder or any developer that wants to maintain systems? No, none does. So this was a huge issue. And what MCP did was something pretty simple. It just sat in the middle. That's all it is. It's an API layer between you and your agent, your LLM, or whatever it is, right? So all these unique APIs we had, they all have MCP servers. So you connect your MCP server to whatever that service is. This is helps you have those connections to all and have that shared memory. And so I'll talk about that in more detail. So just think about that and look at this here. So instead of having these many-to-many connections, which is a huge problem, instead you have an MCP server that can, our MCP server, so there's not have to be one, that can kind of sit in the middle. And now it can talk to all these different agents. So if I had a research MCP server, I can use that research MCP server for any agent that needs research and anything that needs to understand a bunch of stuff about it. Yeah, so sorry, just checking messages. I don't see anything here. So one thing to understand first and foremost is this doesn't really replace anything. Instead, think of MCP as a complement to a lot of the services out there. So even though you see X's here and stuff like that, LangChain, AutoGPT, Crew AI, all great services, but they really didn't have a protocol standard that was shared across other ones. Like they had their own. It wasn't cross-framework by definition. They did have memory sharing because everyone knew that was a problem, but it was limited due to various reasons. And a big issue was tool composability, right? So pretty much all agents require you to generate wrappers around tools, whatever that may be. Go out and scrape the web, generate email and stuff like that. So this is what MCP provided with us. And what you have here is, imagine you have, as I said before, these different agents. One agent's a planner, one's a researcher, one's a coder. Again, memory and context, I kind of use those interchangeably. But that shared memory, that shared context is so important because what is your researcher role? What's your role? What's your goal? What's your role and what's your goal? What's the planner supposed to do? What's the researcher? What's the coder supposed to do? So they're all messaging. If they get messages in shared context, we can better understand intent and trigger these actions. So this unified memory layer across agents is important. And again, I'm not speaking so much yet. What is that memory layer? Is it a RAG database? Is it just in memory? What is it? That's the protocol kind of left that open so people can build upon that. Structured messaging, which I'll show you in a minute, was pretty simple, pretty easy using established JSON format. But most importantly, it gave us a place to look for metadata. And then it clarified and solidified the fact that agents have to know their role, because sometimes that was a bit fuzzy. And how do you, with different frameworks, how can you be clear about an agent role? So if I'm a researcher and I got this planner agent talking to me, can I just ask it what its role is? And can I understand the system prompt that's telling it what its role is? That would be helpful to know. Another big one is, you've seen this, if you've used ChatGPT 5, what they're doing is they're using a model router, an LLM router. Depending on the query you ask, it's routing it to a fast thinker or a slow thinker, giving you a fast answer or a slow answer. Task router is almost the same, but this can be for routing tools, calling and stuff like that. But you can build these dynamic workflows via orchestration that will send your tasks going in a certain direction. And this was important. Remember I said that debugging wasn't working. So now I've got a central place where I can understand log the messages, because imagine you're calling 10 tools in a tool chain. If you think back to the example I showed you in the venture thing, like looking at research reports. So let's say a deck comes in. I want to read the deck. The deck may, let's say the deck is about, the pitch deck that we're getting from a startup is about robotic fruit pickers. So I got to go through the deck. There's a team of 4 people on the deck. Let's say I got to go research through LinkedIn who are the team members, look them up. Is there anything about them on if I do a news search, academic search, have they written any papers? Let's say they're referencing a few papers. Then my agent has to go and look at those papers. Were they highly cited? Did a lot of people read those papers? Let's say they publish something and they have an open source repo as well. Well, what is Hacker News and Reddit saying about this GitHub repo? How many stars are they getting? How many forks? How much activity, like bugs and stuff like that? Like that agent can go through that deck and do all this work that a junior analyst at a VC firm would, because it knows the tools to call in that audit trail, right? So if I'm asking it to do all those things here, what happens if the archive or a Google Scholar link is down? So what happens with the agent that's trying to do research, right? So all these messages from all these tool calls get logged, because a lot of the input to the tools are important, the output to the tools are important, and what happens if something goes wrong. So that audit trail is usually important. So let's look at the architecture. Architecture is simple. You have roles like planner, researcher. You have a message flow through the context layer. You have task chains, right? Very important. Like you can't have a multi-agent system. Like what's the point if you don't have a chain of tasks? Kind of like why LangChain got its name and Crew AI has its name. And orchestration, a fancy word we use in engineering, but imagine an orchestra where you have all these different instrument groups and the maestro or what have you is conducting the orchestra. So orchestration can be serving up these various agents and tools, and it can be prompt-driven, human-in-the-loop, rules-based, autonomous, whatever. MCP is pretty flexible in that. So it doesn't have to be, so people usually think agents fully autonomous. No, it can be very much old school rules-based code, human in the loop, prompt-driven, whatever you think. And the key thing here is the system remains modular. And I wouldn't say debuggable because I've tried it and I wouldn't say it's solved all the debugging, but it's definitely easier than trying to look at that big ball of twine interconnected agents you saw before. So you can try and trace agent decisions, to see how it's swapping roles in and outs and where it's kind of leaves in the thread. Like if you ever used the Anthropic or ChatGPT or whatever other models and you look at the reasoning trace, like how it's going through that, you can turn on the reasoning trace. Exact same thing in your agents. You always want that reasoning trace in your APIs and your agents is a big part of it, right? Because again, for the most part, we're talking about building systems here. And this is if you go to Model Context Protocol, and again you read that document as I said, you'll see this here. This is one of the parts where I'm kind of confused about it because they talk about a host. So again, client server architecture, which is going back decades. So like right now you're on StreamYard or whatever platform you're using. We're actually using client server protocol to run this webinar. So it's tried and true, and MCP is using that, and I like that. But the problem is they have a host, a client, and a server. And to be quite frank with you, I keep getting confused about what's a host and what's a client. And you can look it up, and there's very clear definitions of it. But I mean, in my work, I think that's sometimes confusing, the host client. So a host is an environment where the model operates, like an interactive development environment. An agent, and it could be another agent, user interface. I'm going to show you. Here's my cursor, which is my interactive. It's my development environment. And I'm actually using MCP in here, so that's one of my clients. I'll also show you Smithly AI, which you can use as a client as well if you want. So clients can be a lot of different places, and they're also hosted, of course. So I don't know. I kind of use and client's supposed to be a lightweight adapter, but to me, maybe that'll get clear. But I kind of get these two confused, and I wonder if they could have simplified it. But anyway, no judgment. But to me, the servers clear, right? And the interesting thing about an MCP server is you can build an external MCP server. Let's say you're Amazon and you wanted Amazon, you wanted to, for your Amazon API, build an MCP server so people could connect to that MCP server and query your products. Or let's say you're a law firm and you wanted to build an MCP server to your document database. You can absolutely do that. You can build your own MCP server and actually show it in the code notebooks how to do that. You can build your own MCP server. And so an MCP server, because of the name server, people think it's external to the company. It doesn't have to be internal to a department, company, organization, or external. And here's a good example, which I'm going to go to in more detail. So if you haven't used Smithly AI, again, the link is going to be in the notebooks. In the resources. But Smithly AI is a great resource because I can go in here and I can play around with a bunch of MCP servers, right? So if I go to, if I look for Amazon, here's an Amazon thing. And the cool thing about an MCP server is you can build an MCP server for somebody else's service. So I think Silicon Valley Insights, I don't know who they are, they built an MCP server for Amazon, which is pretty popular, 15,000 calls in the last month, right? So somebody can take your API layer, which is open, freely accessible. Like some of these, I think, have to have an API, but So if you go to Amazon product search, you can see here, like, so remember we talked about MCP server tools. So here are the tools. It's giving you access to a set of tools. Find products, shop for items. I don't know what the difference between the two is. Get product details, get search options, get cache stats. So I guess if you're Amazon reseller or whatever, this could be useful to you. But what you can do is you can use these tools. And what's cool as well here, this is a list of clients that are available right now. You can try out a few of these: Claude Desktop, Claude Code, Gemini. I use Cursor as a client. And also this is kind of a client as well here, because what you can do here is you can go here and say, I'm not sure if this is working today. Some days it works. I don't have to say on Amazon. So it's supposed to connect to Amazon. And I'm getting ahead of myself, but this is the MCP protocol. And here's kind of like human in the loop. It's asking me to approve. If you're doing the full API, you could do that, or you could just automate it. And I'm not sure if it's going to work. Yeah, but anyway, it doesn't matter. So that was a quick kind of an idea of like an MCP server architecture. So you can see the host client server process kind of working there. So again, this is a clear picture of it. You have tools, which I just showed you, the get and the restart. The resources. So what's the difference between a tool and a resource? It kind of blurred a little bit, because you could put accessing files could be a tool, but giving access to those files could be a resource, right? So it's a bit different. But MCP has protocols for doing both. And then prompt. As you know, I'm a huge proponent of prompt engineering. We talk about that in our bootcamp a lot, and we have a whole course on this. So like everything else in LLMs and APIs, prompting is a huge part of that. So well-defined prompts as part of because that's how the agent knows things to do. How does it know how to do it? Because you're giving it prompt templates and stuff like that. So here's some hosts. I'm going to skip over that. How MCP, as you just saw, works under the hood. It's kind of like it uses JSON. It has tools, resources, and prompts. It has security credentials, which is very important, because you don't want people accessing MCP, which accesses an API they shouldn't be accessing. And it is session-based context. So I'm going to go over this stuff a little quickly in the interest of time, because there's some shit I want to show you. So that's Smittery. It's a marketplace. It's got over 8,000. I think they cleaned out some, because the number seems to have gone down. But they have over 8,000 MCP servers. So what I would advise you to do is go around, play around with Smittery. Better to get hands-on, even if you're not coding it. And you can see, you can kind of read here how it works with the JSON here. So you can say Amazon product search, the command it's giving. This is the API command, and where that command is going to, that's actually going to not Amazon directly. It's going to Silicon Valley Insights, and then they're doing the Amazon product search, which is wrapping the Amazon API. And see, there's a key here, an API key or something like that. It's also got TypeScript, and Python, which is kind of fun. So if you want to put this in your Python code, you can as well. So that's kind of one key thing. And then prompts. In computer science and software engineering, we have this idea of what's called first class, like first class data, first class objects. That means they're top level. They're not kind of like lower in the stack. But here with prompts, it's pretty simple. You give it a name, an argument, some description, tell if the argument's required or not. So these prompts are pretty open. Like there's not a whole lot here, because you can basically prompt anything that you can think of for it to do. But it does provide consistency and transparency, because when you're telling the MCP server, you're giving it your prompts. It's not like checking the window. Now it knows what you're doing. These prompts are context, right? They go into context, go into memory, and you can reuse those prompts every time you fire up the MCP server. So prompts are just pretty much like you would write into ChatGPT or Anthropic, right? But you would sometimes have arguments and description and things like that for it. Tools, web search tools, emails tools. would have been good if I had an example of a tool here, but you know, anything you can think of, if it has an API wrapper, it can be a tool, right? And again, I'm skipping over this pretty quickly. And then JSON RCP2, pretty much JSON is the lingua franca of the internet these days. It's just a messaging protocol that's used to move things across. So this is a request for MCP. This is a response, and this is the notification. So again, I know there's a little bit too much detail for some people, but a server has to match the request ID. If you're asking for something, you have to do it with an ID and stuff like that. So study that in your own time. Here's one more example, kind of drive it home. So if you want to get hands-on, I would advise looking at some of these hosts here, trying out MCP with some of these hosts, not just Smittery. So here, if I go to my cursor setup, if I go to my settings, I want to show you where it is. If I go to settings and I go tools and integrations, I can see here I'm connected to Slack, I'm connected to GitHub, but I'm also connected to MCP. And right now I've got two MCP servers I'm using. One is Amazon Product Search and the other one is Paper Search. And if I click on this one here, you can see I got 11 tools. I can search archive and see here the MCP arguments. Like you can see the arguments here. It's a query search. I want to search for machine learning. Maximum number of papers I want is 10 and returns a list of papers, right? And I'm not really describing the query description, stuff like that. So you can see here with that prompt, I'm basically telling it what my query is, the number in an argument format. My first argument is the query. The second one is max results. And another one is return. An agent can take that prompt and basically understand that tool protocol and build that query off it. Other one here is these down. If I want to download these papers, or search Google Scholar instead of Archive, I can do that as well. And here, because I've had these MCP servers installed, I can call things like here. I was calling my and you can see it as well, and in my Amazon one here, different tools I could call. And here, I just ran this before we got in here. I asked it, I want to buy an air fryer. Tell me air fryer. So went to that MCP server, get me back, I guess 5 air fryers, gave me the price, told me some functions here. I can click on that and go to Amazon, I guess. That looks like a proper Amazon link, so I'm going to just take its word for it. Up here, further back, I was asking MCP about papers related to agentic workflows, and it came back with a number of papers. So obviously this is via the chat screen, but imagine if I'm coding this up, how powerful these MCP servers could be. And remember, all I did here was just give it a prompt query. I didn't build out all the agents, didn't build out the workflow. I'm letting MCP do a lot of work for me. So obviously I would want to encapsulate my kind of workflow in my agents and my multi-agent systems. But you can see how using this client, how MCP has made a lot of things simpler for me. And again, if you want to see all the things, all the workflows, it can make simple for you. Is just browse this like DuckDuckGo, web search, Neo4j, which is a graph database. Sorry, Neo4j here again, memory server, some Microsoft thing, dictionary services. What is that? That's decoding, translating, financial modeling. Like if I was to go here and say stock trading. And again, this is not the only place we're looking for MCP servers, but share modeling. Like there's at least 8 different market ACPs there. Robinhood. Sure, a lot of you use Robinhood. Alpaca is another decent one. So that's kind of key. So let me get to, there's a quick way to connect cursor to MCP if you want to do it. And here's a summary slide, which I don't want to go over. And then I want to show you real quickly, because I know I'm running out of time here. If you want to code this up yourself, here's lesson 1, which is orchestrating a multi-agent system. And don't worry, these notebooks are pretty verbose. I put a lot of text in here. So explaining how to build a multi-agent system. Here, I think am I using Crew AI or small agents here? But you can see the agent running. So that's the first one. The second one here is, this is Crew AI, building a multi-agent system with Crew AI, which is another of our favorite ones here. And this is true multi-agent system. So the first one is showing you how kind of hard it is to build an multi-agent system. Second one is a little better with various APIs. And then the third one is, kind of if you want to build out your own MCP server. Because for the most part, I haven't built a production-ready MPC server. We're just mostly using, we want to use other people's MPC servers because we don't have anything external facing or that we need something heavy like that. But this notebook here will go through and help you understand how to build out an MCP server. But a few more slides I want to get to. So this is kind of like a resource slide. Read this for all the MCP capabilities because people say, what about security? What about write actions and read actions, exception handling? So it's got tool invocation, context sharing, streaming, session state, multi-agent coordination, resource listing and directories, and error handling, exception handling. So these are some of what's the resources, capabilities available. And I think this list will keep growing. And again, this is just a kind of a cheat sheet for you. Like you figure out like, hey, I want to do event trading. I really care about live streaming, like, stock streaming or whatever, streaming processes or event-based processes. So look at this. And then, this kind of gives you an idea of typical use cases, live results, knowledge retrieval, document Q&A, updating notions, editing database. So we use this one here, write actions and updates a lot because we're writing to notions and stuff like that. Other thing is MCP. This is where it starts to get the wheels come off the bus. There's someone asked about message, like it's spoken hub. Yeah, it is to a certain degree, but even though it's RCP, there are different protocols like standard input output if you want very high performance, low complexity, good security. HTTPS, which most of them run over, is not great, but it's also the transport it uses. Kind of technical, but you can also specify your transport, right? Because let's say you're doing this for stock trading, you probably want to use a remote procedure protocol, RPC, gRPC, for very high performance. But having said that, it's actually quite slow. And then another thing too is running an MCP server. You want to run it yourself. Reason why I don't do it is this is a single server, and again, this is just a ballpark. But memory usage could be 50 to 100 meg. You're running 10 MCP servers. You need a gigabit or two. High CPU usage network, so you want to be careful of your GPC or IBM or Amazon bill if you're running your own MCP server. If it's getting hit a lot, especially. There's never any free lunch, so it's not some thing that you can just go out there. And then my last thing here is remember I said the good, the bad, and the ugly. Well, let's get the ugly. MCP, I'm sure the security aware folks out there. There's been a lot of scare tactics about AI, and a lot of it's true. Like deep fakes are fucking terrible. But a lot of people say about data poisoning and modeling poisoning. It's kind of hard to do that. But prompt injection, where you got an MCP server, like see how people are building MCP servers for somebody else's service. So what's to stop someone to building an MCP server for Amazon, and then it asks the agent for, oh, by the way, put in your credit card. It'll give you all the servers you want, and all of a sudden it's stealing your credit card information because it's not actually Amazon, right? So prompt injection and stuff like that is real. I'm very worried about that. Malicious agents, because you're handling a lot of control to an MCP server, especially if you're using somebody else's MCP server. What if someone hijacks that MCP server, which is not that hard to do? Tool poisoning, right? Sorry about the misspelling here. This is how you know that I'm writing my own slides, not having ChatGPT with. But tool poisoning. Let's say the agent goes out there and says, context engineering is a big thing now. Give me a research paper in context engineering, and I write a context engineering tool. No one knows what the hell it is, and it could be spreading false information, trying to sway public opinion about something. Who knows? But poisoning in AI is a big topic, but tool poisoning has never been easier because do you know you're actually connecting to the tool you want to? Hey, this thing searched the web. Well, we'll search the web. What if it injected its own information that it wanted you to know into those results, right? So tools and servers, like this is when I love name squatting, right? Like Amazon product MCP server. Like which is the real Amazon product MCP server, right? Or what if I want to do, quant investing MCP server? How many quant investing or crypto investing names are going to be out there? Like you have this name squatting, and then you have overwhelming tool choice. Like literally, I showed you Smithly, which has got over 8,000 MCPs. How many MCP servers you need? I don't know, but just like there's overwhelming amount of information in AI, now you've got overwhelming tool choice. Operational pitfalls, the token cost explosion. So please, before you do this, think about token costs. Okay, so Gemini is charging you 5 cents per million tokens or even less. Amazon very cheap, but when you're tooling all those, when you're chaining all those tools together, tokens in, tokens out, all of a sudden you're using millions and millions of tokens for something. And I love all these demos where people are running 12 multi-agent systems in parallel. First of all, how many trees are you burning down? Do you really have to do that? Are you doing anything useful? Think about the energy cost there, just because the VCs, ourselves excluded, are throwing dollars to these companies so they can do it at less than cost. Think about the energy consumption here. So I those kind of demos drive me crazy because they're not real, because if you're running that many tools in parallel, you're really taking advantage of somebody else's low token cost, which is fine. I do it myself. But I don't know. This will eventually come back to bite you, because I know the token cost keeps getting lower, but the token cost gets lower, but the amount of tokens you use keeps getting higher. So obviously your bill's going to get higher. Documentation gaps, it's not all there. Performance. Yeah, MCP outputs a lot of JSON. So we found it's slow. It's overly verbose, and JSON, everyone knows, is overly verbose anyway. Latency, it's slow. I already said that. Did I say that? Yeah, it's slow. And sometimes that can be in our engineering, mine in particular. So better engineers, myself, can lower that latency, but for a lot of use cases we find it's too slow, because it hampers our reliability and performance. And what you find a lot of people is they'll try an MCP server and say, okay, well, I gotta, that's having one API for many tools is great, but I gotta go back to one-to-one because my thing demands it. And then compliance and accountability. Yeah, a lot of these MCP implementations, they log their actions as service accounts. And even though they're printing out audit logs, it's still really hard to track down, well, which service is doing that, right? So it's hard to attribute, like imagine there's a breach and stuff like that. Yeah, and I still don't think the logging is up. And that's not MCP's fault per se. Like when you're building multi-agent systems with lots of tool calling, MCP, this is more that MCP is not the panacea, as I was saying earlier. There's still challenges around this. So I don't want you walking away thinking, hey, go back to the bosses or your colleagues. Say, MCP is it. I just heard a talk from Sheamus. We got to do this. Yeah, do it. Play around. See if it fits your use case. If it does, great. Like everything else, it'll work for certain use cases and not. But MCP is not the hammer everyone's telling you about, and everything else is a nail. Just like LLMs are not a hammer, everything else is a nail. We can do that. So that's a getting started slide. So for these resources, if you want to click that, there's a link. If you want to take a snapshot of that, that's a link to the drive with all these resources here. Where's that? With all these resources here, including the slides, and then the video recording will be out later. So yeah, sorry, I moved away from that. Stefan is asking a good question. How much does self-proprietary MCP handle these concerns? Yeah, like look at that list. It's a long list. I think none of it or some of it, right? depending how you build it. You got a lot more freedom when you're building it yourself. You can enforce certain rules. So you're not going to deal with poisoning. You're not going to deal with attacks. You're not going to deal with your auditing, your logging should be better. Your latency could be a lot lower if you're willing to spend more on a fast server. Because like, imagine you have an API to do a web search, right? And you just call the web search. How fast will that web search run? MCP is going to do that web search in the time. It's time t plus whatever latency you have because you have an MCP protocol there. So even if you can get your MCP protocol down to milliseconds or nanoseconds, you still have the latency there, right? So that's what I'm saying. Like, latency is like MCP can be slow, not because MCP is slow per se, but the tool chaining is slow. So the tool chaining is slow, right? Or I don't know, it could be MCP's fault, because if it's deciding which tools to call and doesn't understand the latency, and that's not something that's maybe that's a prompt. Like, maybe it tracks the latency of these tool calls, and if you're doing a web search, something like that, we can use any MCP server, do one that's fast, right? So that's a good question. So I thought I had a slide for A2A and stuff like that. I'm kind of out of time here. Yeah. So yeah, these are all the other ones here, not just A2A. Agent to agent seems to be getting some traction. That's Google's, I believe, stuff like that. That's more peer-to-peer, and that's a great thing I was just talking about, because MCP's got a lot of traction right now. A2A, I'll see it. I've only used this once myself in a kind of a toy project, but I did like it because I found, for one thing I want to do MCP for, I found A2A could be used. And of course, these are not necessarily mutually exclusive. You can, I know it sounds more complicated, but you can blend all, if not parts of these to work. So a lot of people think that if I use MCP, I can't use A2A. That's not true at all. They don't compete to each other. And A2A is especially good for long-lived dialogue and stuff like that. There's another one out there called ACP. It's got a better focus on audit, supposedly. OpenAI has their own kind of thing there: LangChain, LangGraph, Crew AI. So yeah, so there's a lot out there, and as I said before, there's no one protocol enforcing to rule them all. Yeah, I know it's frustrating. This may not be what you showed up today and hope to hear. I apologize, but what we used to call, and we still call in the business, this is job security, right? People keep thinking AI is going to make things simpler. It makes things complicated. That's why I don't think AI is going to replace your job. It's going to rewire your job. So you have to understand what that rewiring is. But you know, if I'm using vibe coding now, my job is to be an excellent prompt engineer, to be great at prompting and not necessarily coding anymore. All right, everyone. Thank you so much for listening. It's always a joy and a pleasure to impart the limited knowledge I have, and keep learning, keep connecting, and stay tuned in what's going on with AI, because it's changing so rapidly. So bye for now.